All right. So as you can see that we look at our tester, our rig tester, as basically a 3-layer pyramid. If you look at it from the bottom layer, we look at this layer is really meant for testing as far as compliance for the E201 or A1. It verifies the interfaces that they meet the standards. It also is used for test performance for large load scenarios. There's been cases out there to where you're testing performance, but or let me take that back. You're testing compliance and everything complies just fine and everything's working fine. But once you start scaling up, and depending on the type of scenario that you're working with, those KPIs could be overwhelming to the RIC, and there's cases to where the RIC just stopped working. So this layer is meant for not only just compliance, but also verifying the scalability of the RIC. Now, if you go to the middle layer, this is your RAN scenario. So think of this as a system level emulator or simulator. So this gives the customer the flexibility to design what they want in a RAN scenario. So it gives you that flexibility. So in other words, like if you are training an X app or an R app, or just you want to mimic something out there in the field, this gives you the RAN scenario, or the RSG gives you the ability in order to do that. So you can think of it as a virtual environment that has the flexibility of the real world environment. So in other words, we can, in the RAN or the RSG, we can do advanced L1, L2 modeling, so scheduling per TTI, based on a real network, realistic traffic scheduling, such as round robin, proportional fairness, and QoS. And also, depending on what the customer utilizes, maybe they have slightly their own scheduling algorithm, and we can just work with them to implement something like that as well. We also, you could utilize the MAC, the PDCP, and the RLC layers at this, in the RSG. You also have slice configuration within the RSG, CQI measurements, and also we support in the RIC tester LT, NR, TDD, FDD. You can also design network topologies. You can design different topologies. In other words, you want to create the coverage for indoors, configuration of different base stations, different types of UEs, technologies. In other words, cars or pedestrians or indoor UEs. So this can be done like as far as the antenna, you can set antenna tilt, azimuth, power, gain, pattern, basically realistic commercial antenna patterns. In the RF environment, of course, when you're defining your antenna, you can set the UMA, UMI, you can set it to be rural, indoor, outdoor, and this, of course, is based on the 3GPP 38901 spec. And of course, we have layer 3 modeling with the racks. We have cell reselection, cell handover, RFC states, transition, paging, and then, of course, capacity and scaling. So as far as low latency, high capacity simulations, performance meeting the highest, requirement for RIC testing, and then KPI reporting. We're ORAN compliant when it comes to KPI measurements, reporting, and closed loop testing. So there is some level, of course, when it comes to the RSG, there's some level of abstraction that's going on. And we are not building a realistic or a real base station, right? So some of the underlying protocol stacks, this is why we call it the system level tester. We're not creating everything. What we're doing is we're giving you the data sets that you need in order for the RIC to take actions based on the network, or to optimize the network. So we focus on emulated all the information in the RIC for all relevant ORAN use cases, and of course the use cases as everything is going around like energy savings, right? Traffic steering is another major use case. So the RSG gives you basically a rich data set for offline AI ML model training. You can emulate hundreds, if not thousands, for long periods of time. You can do this over weeks if you wanted to train your AI models. You can also introduce errors. You know, it's one thing when you're training AI and it's getting a good set of data all the time, but what happens when it gets a bad set of data? So this is really the basis for the intelligent RAN controller, to get data, to get this data from the operator somewhat taxing. And then if you do get it, it could be limited in scope. So for app developers, this is actually, they're excited about this because they're not dependent on strictly getting the information from the carriers, if you will. You can set up your own network to mimic that network in the environment to train your apps.
And just a question here, sorry to interrupt. So after you've trained and so on, is also the network responsive to O1 commands, for example? So if you want to shut something down and so on.
So yes.
Can you close the loop?
Yeah, so that's what I'm gonna get. That's the top level right here.
Okay.
Yeah, so I'm getting, you're just ahead of me.
Thanks.
So also one comment, Travis, here. So you said you probably don't need the operator data, right? Like definitely it sounds very promising. So just wondering, like, as in how do you generate this kind of data? Is it like you collate from multiple operators? Because it could, like, all these ML models and all, they are highly dependent on the data, right? Like,
yeah,
so
correct.
is there any high level kind of process you follow to generate? Yeah.
With any testing, right, you're always, especially in lab testing, this gives you the flexibility to generate a large amount of data in order to train certain things. And you can take this testing, and not just the RIC tester, but any type of tester gives you that ability in the lab to test specifically, to replicate somewhat what's in the field, correct? But you also at some point want to grab a subset of the data that's actually out there and test with that as well. And we are, I believe coming up, there's some features that are going to be, you can actually, once you get models, you'll be able to upload models to the RIC tester. But at this point, you can, it has the flexibility to mimic pretty much even more complex models that are out there in the real world.
I see.
I do have a video on, so the AP or the app validation engine is really the closed loop, as what the other gentleman was referring to. And I do have a short video on that. But at this point, I'll finish talking about it first, and I'll show you the RIC, what it looks like. And right now I'm running a test, and the test is really just a default. So nothing specific or geared toward any type of use case. It's just default. But I will show you what it looks like and how it's configured.
Travis, if I may, 1 minute. So basically, Wi-Fi and Steam from Intel, they have an ML model trained on an actual data set from Telecom Italia, which has been publicly available. Now, their model is trained on that. Now, we are going to do closed loop actions, okay, on synthetic data, which is generated by via RIC tester. So I think his question is that maybe the data that is synthetically generated should be as close as possible to the real life data on which the model is trained. So that's a goal. I mean, is that possible?
Yes, that is correct. Yes. You're implementing something with this scenario, the RSG, you're implementing something that is not going to be exact, but it's fairly close to, I would say 99% of what. So when in the app or the AV engine, when you do the closed loop testing, what it's predicting and what you see happening, you should see actually in as you implement that in operations. Does that make sense?
Yeah. Yeah, for the RIC forum, they really kind of saying repeatedly, hey, it should be as close to reality as possible. And with a straight face, we want to say that, hey, it's as close to reality as possible. That's the goal.
I agree. Yeah, no, I agree. If you want me to get more information on that, I can.
Please.
Yeah, just okay. So we are looking more towards implementing more complex scenarios. So as you know that in release 17, it starts talking about UAVs, UAS, and there's a lot of universities out there that are actually starting to experiment with, especially in the ORAN case, experiment with the drones, if you will. You know, first just kind of repeaters, if you will, or in the future, somewhat a drone acting as an RU or acting as an RUDU. So these are more complex models, you know, because they have 3D mobility, but we are looking at implementing these kind of features in the near future because we are getting so much ask for it. So right now we emulate a lot of, you know, you can emulate cars, trains, pedestrians to different levels of realism. You know, in the new release, you have synthetic maps. You can import a GIS map and cars and pedestrians. The cars can roam along the streets within the map, and the pedestrians can be actually outside of buildings, and you can have UEs within buildings within that specific map as well. So we are moving forward to implement more realism in the RIC tester. So the app validation engine basically is what we talk about, the closed loop. So once you've trained your app, of course, you want to see, you know, how it's going to operate. Is it going to do what you think it's going to do? So we create the environment to test, you know, that equipment or software. So we collect all the data, KPIs, as we know in the decisions. We also use our own AI to derive intelligent insight from our engine. We can use it for offline mode and online mode in the future, online modes in the future. Before making changes, the network, you can use the AV to determine how it will affect the network. So for example, if you increase the power by 1 dB, then will it improve? But increasing it to 2 dB, maybe it harms the capacity or some other QoS KPI. So these are things the app validation engine can do for you. So based on our experience, our rich experience with testing all over in universities, our experience with the testing of different scenarios and variations, we can already predict the results before it's implemented in the real network. And that's what I was going back and saying, that when you, as far as the closed loop, you want to see how that app is going to act in the before you put it out there, then you'll be able to do that with the app validation engine. So does that make sense? This will also give you the ability to, because, you know, it's one thing to test one X app or R app, and some of the X apps work hand in hand with the R apps, but as you grow, as your RIC gets more and more apps, there's the potential for conflict, right? So, so there may be some apps that conflict with each other. So how do you deal with the conflict mitigation? So you can have some near real-time running together, striving to achieve some different goals. And it's going to be unavoidable that there will be some conflicts. So for example, if you take an energy saving app and a coverage capacity optimization app, they are running. So the energy saving app is trying to save on energy, but the coverage capacity optimization app is trying to, you know, expand the power to or coverage, there may be some conflicts there. So how do you mitigate that kind of stuff? So that's another feature of the app validation engine. Any questions? Is everybody still there?
Yeah,
Just
yeah.
checking. Oh, okay. Just checking. It was quiet. I'm like, did I accidentally log out? So here is the RIC tester. It's a browser UI. I don't know if any of you have used it before, but it's a browser UI. And like I said, I do have a test running. You can see it running here with the KPIs that we're receiving. And you can see I am actually using a gist map. And the gist map is a newer feature. So there are some slight, like you can see some of the cells are outside the map. That will change in the near future. That'll be resolved. So everything will be within the map. But you have other ways to configure the scenarios. And you can see here, each one of these sites has 3 sectors. And you can see here, we let you know when something has switched from a different cell to another cell. So you can see here, as B13 profile to B2, it switched at this point. And this is up here. There's various cars indoors and pedestrians running. You can actually click on any one of these. So we keep track of them all. So you can actually keep, you can click on any one of them to see what's actually happening within that. And you can see here, it gives you the bandwidth, the throughput, and it also gives you the throughput based on the V2X or slices that we have configured in here. And this also is configurable. So this is just the default. This is what's here, but this is also configurable. So up here is basically your RAN scenario generator settings in here. This is where you're going to set global settings in here. And some of this stuff you can do via the O1 interface. So for example, like if you're doing energy saving and you want to, you're running the test and you want to immediately turn a cell off, you can actually send a command via REST and turn a cell off, or you turn it back on. You can turn a cell off and let it, in other words, if it's at 3 dB, you can, tell it to turn itself off over 30 seconds by 1 dB. So in 30 seconds, it'll be off. You can tell it to turn it back on. So there's various things you can do via REST and netconf in here as well.
Mm-hmm.
And
this is fully O1 compliant, right? I mean, I can send on-off commands from this, right?
you can send on and off, correct? There
So,
may be
no,
there may be some things that, so I just need to, we are compliant, but maybe there's a feature that we're implementing that hasn't been implemented in this version. I just need to find out. So
okay, but in general, it's kind of O1-ish. Yeah.
Correct.
Okay.
Yes.
Now the question is that in the previous slides you showed the energy saving. This is pretty much you are modeling based on the RU power consumption, right? Nothing else. You're not looking at cascading effect of CU and DUs and all that. Just radio head, right? Or you consider anything more than that?
Well, so you're defining here, and as far as multiple CUs or DUs, you're defining that here. So in this case, you have different ways you can define your topology. So think of this as your canvas, and you're putting on your canvas what you want, not how you're going to define each element, but what you want on it. So in this case, it's the number of GNOBs. This is actually CUs. The number of sites is actually your RU/DU. And then you're reporting neighbors. So in other words, if you have neighbors out there, you want them to report on if they're around 4 different cells or 2 different cells. You can change this up to 15. And again, each site you can have up to 100 DUs out there.
Okay. So I think last time last meeting when we had a discussion with Baruch, in terms of showing a decent demonstration about this energy saving with traffic steering, typically, based on your experience, how many sites you think it will be give a good idea for 3 or 4 sites, not to get into too much complexity?
So when I recommend starting small so you can gauge, what everything is doing. Otherwise, you can paint this canvas with lots of things on it, but then you're trying to figure out what everything's doing. So I always recommend starting off small, just something simple, and then scaling from there as you get comfortable using it. Just start scaling from there. And again, like I said, I'm showing the GIST map. I think it's a interesting new feature, but you have other ways to define, if you will, your canvas, your map, your layout. You have random distribution or ASCII.
Okay.
So you can see I pulled in Orlando here based on the longitude and latitude. You can define anomaly areas where you want to create anomalies, what areas, and of course you can place those UEs in those areas. And of course the minimum area size and the maximum area size, all this is configurable. If you want to allow overlapping areas, you can. The number of buildings, so you can define a number of buildings, and then you define within your UE settings, where do I want to place these UEs? Do I want to place them in, any number of buildings, or do I want to place them in anomaly areas, etc.? You have the flexibility to do that kind of stuff. So this is where you're going to set up your, I call it a canvas, Bar may call it something different, because this is where you define your area, what's in your area, your cells, the CUs, and all that kind of stuff in here. And this is where you're going to define your technology. So you're going to define your cell profiles, how many sectors you want in a particular profile, your topologies, and this is where you're defining your frequencies, whether it's going to be 4G or NR, your advanced RF models. And again, as I spoke of before, this is going to be defining your antennas. And down here we have, of course, you have sector beams and you have massive MIMO you can define as well. And then your traffic models and O1 configuration import. This is where you define your UEs. Default, it's going to come with indoor, pedestrian, and car. And of course, you can delete these, or you can add to them. In other words, if you want to add a train or something, you could do that. This is where you define, you can add different slices for these particular groups. You can define if it's going to be carrier aggregation for these groups. And so, as I said before, you define your UEs, you define the buildings, and here's where you define where, the number of new UEs you want. So in this case, it's put indoor, and what buildings do I want them in? And it randomizes, so one building may have more than another, but it will put UEs within those buildings that you define in here. And again, you can put anomaly areas in here as well. So if I go to pedestrian, you can see here it's defined anomaly areas A2. And then I want these pedestrians to be around the profile B13, so around these sectors, these cells. And again, your cars as well. And of course,
sorry to interrupt. So is there a provision to change the number of UEs? I think because that is something like we want to do, like at least from the GUI you're showing, like it seems static, but generally like because our energy saving solution would probably trigger every minute or so, right? And then every minute the load or the PRB usage, all these things would be changing. That would be function of UE. So though it goes very granular, like is there a handle on the number of UEs, or even to make this traffic time varying, like the temporal component of the traffic is something that we are looking for in this use case as well.
So if I'm
one more, sorry, Travis, one more question. So do you also have the provision of placing the cell where we want. Like I saw that we can select how many cells we have, and it may be randomly sets it inside some map area. But is it possible for us to specify that, okay, we want one cell exactly at this latitude or exactly at that GPS point?
From my understanding, we don't, but then again, maybe there's something in the works that you will be able to do that. So let me ask that question. And the other, as far as the static UEs, let me see if I understand you correctly. So yeah, typically you define the UEs in here and you run the test and you have this many UEs. What you're saying is then over time, then the app will do something and you may want to dynamically change the number of UEs. Is that correct?
Yeah, exactly. Because like we are emulating probably, so generally the simulators they simulate order of 5 seconds and all. Like if you want to do some kind of like link level simulation, but now for this use case, especially we are looking at time frame of like 30 seconds or even a minute, right? Like where like every 1 minute you would take a decision. So based on that, the number of UEs or even the traffic would be time varying. So yeah, that kind of component, I was wondering if that is there, because the time, like if you typical link level simulation, like they generally last for like some seconds because you have large number of subframes and then you can calculate all the good metrics. But here, since it is order of minutes or yeah, like hundreds of seconds, so that is why wanted to know this dynamic, the temporal evolution of the traffic. Is that feature present, or do you plan to put something like that?
So let me, I believe we've had this question before. There may be a way of implementing that. Offhand, I don't know. So let me take that back to engineering and find out what we are doing. And if we're not doing it at this point, I can guarantee you this is something, because this has been asked many times, it's in a feature set that's probably coming. But let me find out that information for you, and then I can get back to you on that.
Okay.
And then, okay, back to, so as far as the pedestrians in the car, you can define movement and round trip. Round trip is either return. In other words, if you go from point A to point B, then you're just going from point A back to point B with the return. Teleport means just go back to the beginning and restart. So you're not retracing your steps. And then with the car, with pedestrian too, you can actually define how it's going to move. Now on a GIS map, it's going to move based on kind of the road. So if I tell it to go north and then west, 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 or something like that, it's going to look, it may have to go like west before it goes north, because maybe there's not a road that goes north right where it is. So, but this is where you define the movement of that. And these dots, really, the 3 dots are really just randomized. I don't care where it goes, just move it. And this is where you define your slices. And of course, you're slicing, you define your slices here and the EQoS characteristics, but those are actually, once you define them, then they're actually placed in for the UEs here. And you can have, like I said, you can have multiple slices per group. And then here's your anomaly injection area. This is where you want to define what anomalies are going to take place based on what's here. And, you know, as far as the delay, when it's going to happen, and the duration. And then you define the infected areas that you want this to happen in. And then in the end, you have a model preview. This is going to give you your model. So right now it's going to show you omnidirectional antenna, but when you define up here, advanced RF models and advanced traffic models, it will be sectors. So you're going to define sectors, and from the model preview, it's going to look like an omnidirectional. But once you're running, like if you look at the live charts, you can see that there's sectors. So you would see this once you start running. So this is your RAN scenario generator. This is where you define everything that your characteristics of the various configuration that you want to utilize in that scenario. And you can create multiple scenarios, save them, and export them, and then load them up. You can even pipeline them together. So if you have multiple configurations and you want to run a overnight test, or if you want to run a week-long test and you want to automate these various configurations, you know, to run over time, then you're able to do that as well. So when you get down to interface testing, this is the parameters here are specific to interface testing. The only exception to that is, in other words, if you want to send, I think it's in globals, you want to send the RSG emulation to a RIC, you select that as true, and you're going to use this. So whatever RIC you're connected to, you're going to use the RIC IP address here, and that RSG will utilize this IP address in here to send to the RIC. Same thing with the interface. So that's the only thing outside of the RAN scenario generator that's utilized within the interface testing is the IP address here. And here is you're going to define your characteristics for the E2 interface. And again, the A1, the O1 small, and the O1 interface config. And of course, you can define your VES collector and then point that over to the VES collector. And there's also options underneath. If you look here, in some places, you'll have advanced options that aren't checked. So if I click on that and you have authentication you need for the VES, then you can utilize that. But there's other advanced options too that, you know, you can look on here. Up here, you can see that this is JSON that's being sent. You can actually modify this in here if you needed to. I haven't modified anything in here. I've used this. I've copied it to see what it is and then used more of my automation to make any changes. But you have that flexibility to make changes within here too. And always don't forget to save it. And if you're running a test, it's not going to make any changes until you stop and restart. And down here, oh, of course, you have security settings here too. If you need security settings, of course, in my case, it's in loopback mode, so I don't really set any security settings. But you know, and customers, if they need to set you can do that here. So here's your closed loop testing. And I am going to let you view the video because I think it probably gives you a better explanation of, you know, how this works.
Travis, before that, I have a quick question.
Sure.
You showed the power, you know, energy savings and all that. One thing which I think we should show is the KPIs. That means when you do this operation cell on off, the KPIs are unaffected. Say, for example, the typical ones for accessibility, you know, retainability, throughput, something like that. So do you have any such metrics that this simulator measures here?
Yeah, so all these, so these KPIs are actually sent to the Influx database. So you have a couple ways to utilize it. You can look at this in real time. You can also pull the KPIs from the Influx database.
Okay.
We've had other customers pull it from the Influx database and use their own defined Grafana graphs, if you will, to look at the KPIs that they want to look at. You can do that in here. So you can find, like, this is the default method. You have the flexibility to define parameters within here, KPIs you want to look at versus all this stuff. So you have that flexibility. So there's it. I just say it gives you the flexibility to do it either way. So if you wanted to utilize your own to look at certain things, you can. Just pull the KPIs from the Influx database and then put them in another database and then analyze them that way, or directly, you know, show them in whatever Grafana defined graphs that you have.
All right, right. Yeah, at least I want to show that, this cell on-off operation is not affecting customer, the service quality,
Yeah. So
that's
the other nice thing too is in these, you see all the sectors in here by default, all the power is the same. If one had less power, the sector, you would see it as smaller. But once you over the old one interface, say I wanted to turn off the sector, I can do that. And what you would see if you, especially if it gradually turned off, you would see it gradually the power gradually diminishing until it disappeared. So you would actually see that, and then you could look at the UEs that are around there to see how they're affected. Do they switch to another cell? How is the quality of service? That, are they still receiving the same throughput? Is it better throughput? Is it worse? Then you can look at all those different KPIs.
Got it. But that so long as the information is available and this easily can be displayed, it's great.
Yes. In this case, it's just on my screen is probably really small to you guys. So, but you can actually zoom in on this stuff and look at it in more detail.
Okay.
And also there's other stats too. And again, you can define the different stats. It shows you, the blocks being used, like in this cell, it's 100%. You can see in this cell, it's 70%. And then when you get down here, 0% being used. And then you could look at the power here. So you can see it's, and then you can, when you turn off the power, you can see it as well here. So there's different ways you can look at it. It gives you the flexibility to look at it in various ways, whether it's table or.
Okay.
So let me show you the AVE, and I will play this for you. Can you guys see it okay? Is it too small or?
Yeah.
Is it...
Good.
Okay.
There's no audio.
There's no audio?
No.
It is on my side. Sorry. I don't know how to. Of course, that's one use case, but hopefully you guys have an understanding of how it works from that video.
Just a question here, Travis. So, when we say you're switching off a cell, so do the UVs move away from that cell through some handovers, or is it not what we are looking for right now?
Yeah. So the UV should be handed off to a different cell, of course,
Okay,
unless
so-
they're at some location to where if they're in a building, maybe you turn off a cell that there's nothing to hand off to, depending on the power.
So I mean, if there's a scenario like there are 3-4 cells you have created, and you have introduced some number of UVs, and the UVs are also moving, so handovers keep on happening organically. There's nothing special which we need to configure.
That's correct.
right?
Yes.
Okay,
Yes.
sure. Thank you.
That is correct. And depending on the handoff, then you can, and what you're looking at, then you can determine, well, is that UE is the quality of service, level of that UE, is it's being maintained, is it going down,
Right.
What's happening with it. So
Sure. Thank you.
So hopefully all that is helpful in understanding how the RIC test works. I will get questions. I have 2 questions. If there's anything I'm missing, please let me know. Feel free to email me, and I'll get any questions asked that's needed.
And also, we would like to do this, get it installed in a, we have an environment here. So I think the license, the NDA and everything we signed, and just talk to Shushri, if she gonna make it today.
Correct,
That
yeah.
we can proceed installing this, some detailed instructions on how to get and all that. That's, she said, going to be provided. So Travis, you have the contact for that, for
Yes,
installing?
yeah, I can provide the installation. I can help with the installation if you want. You can.
Please.
So that's not an issue. We can get the license once we get it installed. The license is dependent on the MAC address. So once we install it, I'll grab that, and then I can get the license and put it on, and we're ready to go.
Yep. So Dennis, Travis is the contact, and if you could touch base with him and get this process started, that'll be great.
My apologies. Could you please repeat, or it wasn't a question to me?
Excuse me?
Was it a question to me? This is Dennis.
Yeah. So Travis is the contact, so that we can get it installed in the environment that we have.
Okay.
With you guys, Theater has. So I think you please touch base with him. He said that he's going to help you getting the team getting this installed.
Okay.
So he is the contact. So we can get that going.
Okay, thank you. So Travis, would you prefer to stay on the call today, or to have a dedicated call tomorrow?
We can have a dedicated call tomorrow.
Okay.
Yeah, that's fine.
And you are in the US, right?
I am, yes.
In the Eastern time zone, he's in Florida.
Correct.
Okay, and is the same time convenient for you as we have today?
Hold on one second. Let me check my schedule. I do have an 11 o'clock. We can do 10, or we can do 12. Whatever works for you.
So 1 hour earlier or 1 hour later.
Correct.
That's what it said.
Okay, sure. I will schedule then a meeting with you 1 hour earlier. I believe I will talk to the team tomorrow, and we will decide. Okay. I would like to invite also our engineers. That's the idea.
Okay.
Okay.
Thank you.
Thank you then.
Yeah, we are now at the top of the hour, so let's get it going. And thanks a lot, Travis, for it's a great demonstration. So we'll have a lot more questions. So, folks, I mean, especially the Intel team, we ask a lot of questions, and please send emails to Travis and or just questions and all that. So you can.
Sounds good. Yeah.
Please.
Okay. Sure.
Thank you.
Yeah. Thanks, everyone. Thank you.
Thank you.
Thank you.
Bye bye.
Bye.
Thank you very much.